Again, welcome to the SRT 734 class. In these lectures, we're going to study about how to measure the central tendency. That's how to find the mean, media, and also the mode. These lectures cover our textbook, chapter 3. So our main objective in this course, we're going to learn how to determine the mean, media, and mode of a population, and also of a sample. Also, we're going to determine the weighted mean of a data set and the mean of a frequency distribution. Also, we're going to describe the shape of a distribution as a symmetric or uniform or skewed, and also compare the mean and the media for each. Again, the distribution of a data set always depends on the value of the mean and the media. So if the value of mean and the media is the same, then the distribution will be symmetric. If the mean is greater than the media, then it will skew to the right. If media is greater than the mean, then it will skew to the left. And we're going to discuss about this. So first, we start with the measures of central tendency. Here we say a value that represents a typical or central or the entry of a data set. So the measure of a tendency is to find the center of the data set, the values. And see, so here we say a value that represents a typical or central or entry of a data set. Most common measures of central tendency is the mean, media, and also the mode. So now if I have a data set and the outline of the data set is very important, we don't want it to affect the central tendency, then we may use the media. Example will be the income, a salary of employees in a specific company or a city. We don't want to find the mean because maybe the CEO of the company is making $20 million a year and most of the workers are making less than $80,000 a year. So if we are going to find the mean, it will drive the central tendency of the salaries of employee salaries to very high because of the CEO making over $1 million a year. So in this case, we're going to use the media. Also, if we have a data set and we cannot perform arithmetic operation on the data set, let's say the number of cars that are red and the number of items that are blue, etc., or the color of something, or let's say we want to find how many truths and how many false, or how many positive, how many negative of a test. Now we know the amount, but if we want to find the average, we don't want to add a positive 1, positive 2, and then divide by the number of items. So in this case, we are going to use the mode. So mode normally is used to find the measure of central tendency, but the data set in this case will be a qualitative data or nominal data, so we can only perform counting. And mode is more or less like count. So again, let's start with the mean. So the mean also is called the average. And how do we find the mean of a data set? We normally add all the values together, then we divide by the number of values. So here we say the sum of all the data entries divided by the number of entries. And now we use the symbol sigma notation. The sigma notation is a symbol that represents the sum of everything. So if I have a sigma x, it means add all the values entries, which are x values in the data set. So sigma notation is the sum of everything. Then to find the population mean, and population mean, first the notation is mu. So we use the symbol mu. So to find population mean means we are going to add all the values. So they add all the values of x, then divide by the number of values of x. So n will be the uppercase n here means the population size. How many x values we have? That's the population size. So we had, let's say, for example, we have 5 values as a population. So we had all the 5 values, then we divide by 5. So again, uppercase N represents population size. Then if the data set is sample, it's the same. Add all the sample values, then divide by the lowercase n. Lowercase n also is the sample size. So uppercase n represents population size, then lowercase n represent the sample size. So let's see an example here. Here they say there's a prices. These prices are in dollars for a sample of a round trip flights from Chicago, Illinois to Cancun, Mexico are listed. What is the mean price of the flights? So here we are assuming this flight, it's a round trip flight from Chicago to Cancun, Mexico. Now the first price is $872. Second is $432, $397, $427, $388, $782, $397. So this means we have 7 different prices here. 1, 2, 3, 4, 5, 6, 7. 7 different prices. Now the question says we should find the mean price of the flights. So here we are going to add all the values, then divide by 7. So here we say the summation of all the 7 values. The summation is 3,695 when we had all the values. Then we are going to divide by the number of tickets prices, which is 7. So it will be 3,697 divided by 7, and the answer will be 527.9, which is $527, again, 90 cents. So again, to find the mean, always we had all the values and they divide by the number of values. We cannot find the mean if our data set is nominal or qualitative, because we know a nominal data, we cannot do addition. How many patients have a positive test? 20. How many patients have a negative test? 10. We cannot find the average of positive and negative tests. So next we go to the media. Also media, we use it to find the central. So also the media, we use it to find the central tendency of a quantitative data. Now, the first thing we have to do is to put the values in order. That is, sort it in an increasing order. Then we look for the middle value. Now, if the total number of values is odd, let's say we have 7 items, then the middle value will be only 1. But if we have 8 items, then we are going to have 2 middle values. So we get these 2 middle values, then we find the average of the 2 middle values. Now, most of the time, the reason why we use median is if the central tendency of the data set we want to find, we want to avoid the outline data. Outline data are values that are very small and very large. So if I have a set of 10 values and 9 of these values are, let's say, between 1 to 5 or 10 differences. What I mean by 1 to 5, maybe I have 5, 6, then I have 11. So the difference between 6 and 11 is 5. Then I have 3, again, very close values. Then I have one value that is 20,000. So the first 9 values are between 1 to 20. But the next value is 20,000 or 50,000. We can see that if we are looking for the mean and we had all the value and divide by the number of values, the 50,000 alone will make the average goes up very high, unreasonable, very high. So in this case, we are going to use median. When we use median, the median is very robust to the outline data, very small, very large. Because in median, we are going to arrange the values in order. Then we take the middle value. So we are not going to add all the values together. So let's go through the steps here. See here, they say measure the center of ordered data set by dividing it into 2 equal parts. If the data set has an odd number of entry, then the media is the middle data entry. which means if the number of values we have is 13, we get only one middle, or if it's 9, we get only one middle. But if it's even, let's say 10, then we have two middle values, we find the average of it. So the media is the mean, which is average of the two middle data entries. So let's see an example here. This time we have the flight again from Chicago to Cancun, and we have 7 prices still. So if I want to find the median, again, we saw how to find the mean. I will add all the values, then I will divide by 7. But if I want to find the median, I will put these values in an increasing order, sort it in increasing order, or we use the term ascending order. So that's the first thing we did here. 33, 388, 397, 397, 427. And fortunately, we have 7, so it's odd. So we are going to take the middle value. So our media will be 427 or 427. Now let's see, this is if it's odd, because we see we have 3 to the left, 3 to the right, so the middle value will be 1. Now if it's 8, we see that we have 4 to the right, 4 to the left, there's nothing, no middle value. So we have to be, again, very careful with that. The best way to do it, take the two middle value, find the average of it, which will be our next example. So here we have 6 flights instead of 7. So we've again sort it, but this time we have two middle values. So we take the two middle values, then we find the average of it. So our median will be 397 plus 427 divided by 2, which will give me 412. So let's move to the measure of central tendency, the mode. So mode, we said we only use it for qualitative data. If we have to counting is based on counting. So here we say data entries that occur with the greatest frequency. What we mean is that if I have a data set, let's say only 4, I have 7, 8, 9, 10. You can see that these 4 values, each value appears only once. That means we don't have no mode. Now, but if I have 7, 7, 8, 9, since 7, 7 is the greatest frequency or the highest tally, we say the mode will be 2, because 7, 7 is 2. I mean, the mode will be 7, because 7, 7 is 2 of them. Then we have 8 and 9, they are 1. Now, if we have 7, 7, 7, and 9, still the mode will be 7, because we have the highest frequency is 3 sevens. But if I have 7, 8, 9, 10, they all appear only once, then we don't have no mode. So let's say here we say if 2 entries occur with the same greatest frequency, each entry is a mode, which we call bimodal. So what we mean here, I have 7, 7, 8, 8, and then 9. Because 7, 7, and 8, 8 appear twice and the highest frequency, then in this case we will say again, we have a bimodal. The mode is 2 values, 7 and 8. So let's see an example here again. In this example, first, we can put it in a sorting order. Sorting order, we don't have to, but the reason why we use sorting order here, so that the values will be more organized and I can go through them very quick. So we can sort it. And I can see that, 397 appeared twice. The rest is only once. So the average again, in this case, or the mode, will be 397, which is the central tendency, because it occurred twice. So finding another mode, you see here we are using qualitative data. Let's say we have some debate to pass some bills, and we have a political party. The Democrats have a 34 vote, Republican 56 vote, order is 21, then do not respond is 9. Now, if I want to find the mode is the highest tally. So the highest tally here is 56. So the answer will be again 56. And the 56 is a Republican. So here we say the mode is Republican. The response occur with the greatest frequency. Now, comparing the mean median mode, we mentioned that the main difference again is the outline data. Outline doesn't affect median. It doesn't really affect mode, but it affects mean a lot. So here we say all three measurements describe a typical entry of a data set. Now, advantage of using the mean. The mean is a reliable measure because it takes into account every entry of a data set. So again, the mean is very reliable because it uses all the data for its calculation. Now, the disadvantage of using the mean is that since the mean is using all values, if the value is outlined, which means it's too small, it will make our mean to be very small. Now, if our outline is very large, we have a large value, then it will make our mean very large. So here we say the mean can greatly affected by outliers, a very small or a very large data. So this is a data set given to us. They say we should find the mean median mode, so we compare the result. So finding the mean, we had all the values, we divide by the normal values, which is 20. Then the median, we put the values in a sorting order, but when we sort it, remember this value is 20, even number, so the middle values, two middle values we get, which is 21, 22. And that will give us the median. Now the mode means counting. Here we say 20 years. Why? Because 20 years appear 6 times more than the rest of the values. So here we have the mean median mode. And here we say the mean takes every entry into account because you have to add everything together. But it's influenced by the outline of 65 or more. So again, here we say the mean takes every entry into account, but it's influenced by the outline of 65. So the median also takes every entry into account and it's not affected by the outline. The reason why, again, we arrange the values in ascending order sorting, then we just take one middle or two middle. So a very small value will be in the front, a very large value will be at the back. It doesn't have anything to affect, it doesn't affect the median value. And then we say in this case, the mode exists, but it doesn't appear to represent typical entry. So we can see the median is 21.5, the mean is 23.8. So sometimes also a graphical comparison can help us to decide which measure of central tendency best represents a data set. So in this case, we say it appears that the median best describes the data set. So we can see the median in the middle. The mean is very large to the right and the mode to the left. Also, we have something called the weighted mean. A mean of a data set whose entries have a varied weight. So we have an entry, but the weight of each entry varies. They are not the same. The example we did, we are assuming the weight are the same because we don't even consider the weight. So now if we have a weight that represents each value, what you do is that you multiply the weight by that value. Then you add it to another value and its weight if that one also have. If it doesn't have no weight, then you just add. So here, W represent the weight for S. We have S value, so always multiply. If there's a weight associated with the S values, it means we are looking for weighted average. So what we do is that we multiply each weight, each value have its own weight, multiply the weight by each value, and then add everything, then we divide by the sum of the weight. So this is an example given us. Let's say you are taking a class in which your grade is determined from 5 sources. 50% from your test mean, 15% from midterm, 20% from your final exam, 10% also from your computer lab work, and 5% from your own work. And they say your scores are 86, 96, 82, 98, 100. So what is the weighted mean of your score? If the minimum average for an A is 90, did you get an A? So now we have to be careful for the weighted weight. The weighted weight for each score is the percentage of the final grade. So you can see that the question said the test mean is 50%, the weight. Midterm, the weight is 15. Final, the weight is 20%. Computer lab assignment, the weight is 10%. And then the homework, the weight is 5%. But here we know this is our weight. Again, the percentage of the final grade. So to find the total, we multiply the weighted average, we multiply 86 by 50, then we add it to 96 multiplied by 15, 82 multiplied by 20, 98 multiplied by 20. Now when we multiply everything, we add all together, and that's what we have here. 86 multiplied by 0.5 give me 43. 96 multiplied by 0.15 give me 14.4. 82 multiplied by 0.20 give me 16.4. 98 multiplied by 0.10 give me 9.8. And the last value, the homework score was 100, but the weight is 50%. 5%, so it's 0.05. So again, the weighted, we had everything, we get 88.6, but we haven't finished yet. Now we are going to divide 88.6 by the total weight. The total weight is 1, so divide by 1. So that gives us 88.6. So again, that will be the conclusion here. Now next, the mean of the grouped data. If you want to find the mean of a group data, we again have to know the mean of the frequency distribution. What we mean here is that, for example, let's say X, we have 3 values that are 10. Instead of writing 10 plus 10 plus 10, it's 3. So we group it as a 3. So 3 represent the frequency, number of. So here we multiply the number of times plus the value. So it will be 10 times 3. So mean of a group data means the frequency, how many times that value appear, we multiply by the value, which is again the same as if 3 appear 10 times, is 3 plus 3 plus 3 plus 3 10 times will give me 30. We can, instead of writing that, we can just write 3 times 10. The 10 is the frequency, the F, how many times S came. And S is 3. And that's what we have here. Now, when we, instead of dividing by N, we're supposed to divide by the N of the F also. Because that's why we write here. They already divide by N means the sum of F. So if F appear here 3, and then next X appear 2, I have 2 S values. I'm not going to divide by 2, because since the first value, we have the frequency of S is 3, and the second value, the frequency of F is 2. It means S appear 3 first time, S appear 2 the second time. So in this case, I will divide by 5, 2 and 3, not by 2. So that's why here they are telling. Here, most textbooks can write the sum of F here instead of writing N. So this is an example. See soon. So here they say finding the mean of a frequency distribution. To find the midpoint of each class, remember the lower limit, upper limit, divide by 2. So we had the lower limit, upper limit, divide by 2. Now to find the sum of the product of the midpoint and the frequencies, we just multiply how many times S appears, which is the F, times the S value. Then we had everything. Then we find the sum of the frequencies. So here we just had all the frequencies, and that will represent N. Then next we find the mean of the frequencies. So we divide by N. Remember, N is the sum of F. So as I said earlier, some textbook will write the sum of F, which is the frequency for each category values. So it's like, if I have X appear 10 times and I write 3 times, S is, let's say S is 2, and S appear 10 times, I can write 2 times 10 divided by 10 because F is 10 times. So the total F is 10. Now, I'm not going to say S appear once, S value is only 1, so I'm going to divide by 1. No, you have to divide by the number of times the S appear. Or I can write S plus S plus S 10 times, then I divide by X. But just to save time, instead of writing the S over 10 times or 20 times, if the values are 20, we just use the frequency. So this is an example given to us. We know the class interval. So what we did first, we found the midpoint. Then we know the tally. This is the same example we did when we were doing the frequency table and distribution. So this is our midpoint. So now we multiply our midpoint by the frequency. And what it will give us is the sum of all the value times the frequency. So this will be our upper value. Then we're going to divide by the sum of the frequency. So we divide by N, which is 50. Also, the shape of a distribution can be symmetric distribution. Symmetric distribution means we can see here the mean, median, and mode are the same. They are in the middle, and their value are the same. Then, uniform distribution means all the entry or classes in the distribution have equal or approximate equal frequency. So when you have a distribution and how many times they appear is the same, the normal frequency is the same for all the data set, then we're going to have a uniform distribution. Now we can have skew to the left. Skew to the left means the mode is greater than the mean. Now we can find the skewness of a graph, which is the mean minus the median over standard deviation. So if the skewness is negative, then it will skew again to the left, because we're going to get the mean value will be less minus the median value, which will be high. So you get negative value. And standard deviation is positive. So that will be skewed to the left. And we can see the mode is greater than the mean. So the mode is at the back. But this will be skewed to the right when only the mean is greater than the mode. So here we can see that the mean is in the front, mode or median is behind it, and the mode is always back also. So this will give a skew to the right because mean is greater than the mean. So we're going to end our lectures here. Again, in these lectures, we study about the central tendency, how to find the mean, median, and also the mode. We also look at the weighted mean and also the group also. So again, wish everybody the best. And if you have any question, feel free to send an email, or you can also reach me at my cell phone number. Thank you. Good luck.